Okay, today we're going to be doing a separation of mixture lab, and what we have here is a mixture of salt and sand and iron filings. And the first thing I'm going to do is I want to separate all three things. I'm going to weigh my sample. So the first thing I want to do is weigh the whey vote, and the mass of the whey vote is 2.11 grams. And then I'm going to take a little bit of my mixture, hope I have enough of everything in there, and just pour it in to the weigh tray. And that looks like a good amount, so I've got 6.43 grams. So let's write that down, 6.43 grams. And then I'm just going to subtract the mass of the weigh tray from that mass here, 6.43. So 6.43 minus 2.11. That's going to give me the mass of my mixture, 4.32 grams. I'll use that as a basis for figuring out the percent of each component. Now, the first thing I want to do is get the iron filings out. And this can be a little bit tricky, so we need to use a magnet for that. So I've got this gigantic magnet here, and what should happen, I've put it in a little plastic bag so that the filings don't stick to the magnet, they just stick to the outside of the bag. And I don't know, can you get like a close-up of this? So you might see that the filings are kind of jumping up out of the mixture. I'm also getting a little bit of sand in there too, but that can't be helped. Sand likes to stick to the magnet, the plastic bag, unfortunately. So it's not perfect, so that's one thing you might want to write down. And I'm getting a little bit of sand in this. I'm just going to do this until it looks like nothing else is jumping up at my magnet. And I can see a little bit more black. Anyway, shake it off a little bit, maybe I can get some of that sand off. Let's see if I flick it. Ah, no, it's still sticking. Okay, well, it looks like I've gotten maybe most of the filings out. There we go. And I'm going to put my sand and salt aside. And then this is a little tricky, but I'll take another weigh tray. I'm going to write down the mass of that. Good that it's not much different from the other one. That means they're pretty consistent. So 2.13 grams. Write that down. And then really carefully take my weigh tray. I'm going to put the plastic bag in here and then remove the magnet. And that what should happen is that everything that had stuck to the magnet hopefully will come off. Okay, so you can see up close, there's a little bit of sand in there too, but for the most part that looks like the little black iron filings that I had put in the mixture, so it looks like a lot of them came out. So I'm going to weigh this again. That's 3.03 grams. And then if I subtract the whey vote from the mass of the iron, 3.03 minus 2.13, that's 0.9 grams of iron. So that's how much of the iron is present in the mixture. The next step, we're going to be separating out the salt from the sand. So the step is to separate out the salt from the sand, and there's a couple of things that I'm going to need to measure first. So the first thing I want to do is measure the mass of the Erlenmeyer flask. I'm going to write that down. That is 114.31 grams. Now the second thing that I want to do is take the mass of a piece of filter paper. Take that. This is a dry filter paper. That is 1.18 grams. So to separate the salt from the sand, we're going to take the mixture that we have here that's mostly salt and sand. I know there's probably a little bit, unfortunately, of the iron filing still in there, but we did what we could. So I'm going to take that and put it in a container of water. Now what this does is it allows the salt to dissolve in the water. The sand doesn't. So the salt's going to dissolve in the water, and then I can filter the sand particles out. So that should be good. Now I have a filter apparatus set up here. So I folded up the filter in a funnel. I'm going to place that on top of my Erlenmeyer flask. Swirl this around a little bit to get as much of the salt. And then I just pour it in. And it will take a little bit. It's a little bit of a slow filter. I've tried to keep most of the sand in my beaker for now to get as much water out. So the salt water is going through, but the filter should trap the particles of sand. And it's slow going. Then to get the rest of this sand out, I have a scoopula. Just try to scoop all the sand out. I eventually want to just collect it in that filter paper, which we're going to let dry overnight. Okay, so you can probably see that there's still a little bit of sand left in my beaker, so I'm just going to take the squirt bottle, squirt a little bit in there, and try to get as much out as I can because I don't want to lose it. So the goal here is to be able to collect the same amount of stuff that we started with. I think that's pretty good. So we're going to wait until all of the salt water has filtered out, and then we're going to be heating up the Erlenmeyer flask to get the salt by itself. In the next step, we're going to boil off the water, let it evaporate. So I've placed the Erlenmeyer flask on a hot plate, and we're going to wait for all of the water to boil off, which will take a little bit of time. And in the meantime, I've taken the filter paper out of the funnel. You can see the sand that was left over in there. We're going to let that dry overnight and then weigh everything at the end so we can figure out how much sand we have. We're going to figure out the mass of the sand right now by measuring the mass of the filter paper with the sand in it. The filter paper is dry now, so I'm going to place that on the balance, and I get 4.00 grams. So I'm going to subtract the original mass of the filter paper from that. That was 1.18, so 4 minus 1.18. That will give me 2.82 grams of sand. And then next we're going to figure out the amount of salt that was in the mixture. So we found a mistake when I was measuring the Erlenmeyer flask and the salt. So we're going to correct that mistake. What we found was that the mass of the flask by itself weighed more than the mass of the flask plus the salt. Now the only way that that would happen is if the balance was not zeroed out when I took the original mass. So what we're going to do, I took the mass of the flask with the salt in it, and I got 113.32 grams. Now I'm going to mass this again, and I get 112.8. That makes a lot more sense. It should definitely be less than the mass with the salt in it. So I'm going to subtract that, 113.32 minus 112.8, and I get 0.52 grams of salt, which makes a lot more sense.
So now we get to the fun part where we can calculate the percent composition of all the components of this mixture. I'm going to do one calculation for you. And as it says on your sheet, the equation for percent composition is going to be the mass of the component divided by the mass of the mixture times 100. So it's the mass of a part over the mass of the whole times 100. So the part that we're going to look at is the sand, and I calculated 2.82 grams of sand. I'm going to divide that by the whole thing, which was 4.32 grams, the mixture. I'm going to multiply that by 100. When I put this all into my calculator, I get 65.27 repeating. So I'm going to rewrite that as 65.3. I'm going to round it. And it's a percent, so it's percent. So that tells me that Out of the whole mixture, 65.3% of that was sand.